may have heard of energy transfer in your science class. So for example, when we're looking at these two D-cell batteries, this is stored chemical energy. So when we place the stored chemical energy in the flashlight and turn the switch on, it's then transformed into electrical energy. That electrical energy comes out in the form of light and then eventually thermal energy as it heats the surrounding air. Whenever we use an appliance, we're transferring energy from one object to another. And not all of that energy is transferred where we want it to go. And in fact, some of that energy can be considered wasted. For example, when you're using lights at home, it's giving you light output, but you're also getting a thermal output. And this is one of the things we're going to investigate today, talking about light bulb efficiency. An LED light bulb actually is 90% more efficient than a standard light bulb. But we're going to prove that today, again, by turning the code node into a sort of alarm that lets us know whether a light bulb is a lower efficiency or a higher efficiency. Okay, so let's test our light bulbs for any thermal wasted energy output. So you can do this at home pretty simply. I just took a lamp and I'm going to take the lamp shade off. And I have two light bulbs. I have a 14 watt LED and then I have a 100 watt incandescent light bulb. Be really careful working with incandescent light bulbs at home, guys, because they do get warm. And again, we're going to prove this using data that we collect from our code node. All right, so first I'm going to put the LED bulb in and we're going to see the kind of data that you would collect that you would need for your program. So let's make sure my code node is on. And you can hold your code node up. You don't need a holder like this, but I just want to make sure I have it at the exact same distance each time I run this test with the light bulb. So what we're going to do, I've connected my code node to my SparkView software. And the only sensor that we're going to need for this is the ambient temperature sensor. So once this connects, I am going to click on the temperature and then disable the other sensors. I won't need those. And then you're going to want to pick the line graph. Okay, so here I can see temperature over time. I'm doing temperature in Celsius. If you wanted to change this at home to Fahrenheit, all you have to do is click on temperature and then this icon, and then you could change it back and forth from here. So I'm going to leave it at Celsius. And the first thing I'm going to do is just press start after I turn on the LED bulb. And again, we want to measure the ambient temperature around this bulb. So I'm going to let it run for a couple minutes to see if we have any fluctuations worth noting. Okay. All right, so I stopped collecting data just a little bit over 2 minutes in, and we're seeing pretty much what I expected to see. The temperature stayed pretty stable, meaning that it didn't really change or fluctuate very much. We were using the LED bulb. I'm going to now try it with an incandescent light bulb that's at 100 watts. You don't have to use a 100 watt bulb, but you do want to use an incandescent for the second part. And again, be very careful with the incandescent bulbs. You're going to see the data, why that's important in just a second here. All right, so I'm going to turn on that bulb and I'm going to start collecting data again for another 2 minutes, and then we'll compare the two runs. All right, so I did another 2-minute run with the incandescent light bulb, and I'm going to bring up my first run, which was the LED bulb, and my second run, which is with the incandescent light bulb. And as you can see, the LED, the temperature stayed about the same, where our incandescent light bulb let off a tremendous amount of thermal energy that our ambient temperature sensor was able to calculate. So we're going to use this data in a program to create one that will let us know whether a bulb is a higher or a lower efficiency. And you can actually keep the same setup here. before we dive into the program and build it, I'd like to show it to you completed, and that'll give us time for the incandescent light bulb to cool down, because I definitely don't want to touch it right now. Okay, so here we are. Here is the program that has been completed, and I want to walk through with you what essentially we're telling the computer to do for us using the code node. All right, so I've created a while true loop, which again means the computer is just going to run through this program over and over again until I hit stop. Then we have our conditional statement. If the value of the temperature is less than 27 degrees Celsius, that's going to indicate that we have a higher efficiency light bulb. And then I have the speaker set to 0 hertz, which means no sound will come out. Else, if the temperature is not less than 27 degrees Celsius, then it's going to indicate a lower efficiency light bulb, and it's going to give an alarm using the speaker on here to give us that indication. I want to point out something new that you may not have used yet, and it's the text output block. So when I walk you through this program, I'll walk you through how we create those and then how you can see the verbiage on your screen. All right, so code node is still on. I'm going to get it back in its position. My incandescent light bulb is cool enough to the touch now. I want to do my LED first. Okay, same distance, everything's good. I'm going to use my book to help me with my coding program, and you can also refer to it if you want to learn more about thermal energy output. All right, so let's create the program together. And I'm going to start a new experiment. And I'm using the ambient temperature sensor. Disable the other sensors. Go ahead and choose the line graph. And then click the code puzzle piece icon. All right, let's start with that loop. So while true. Then I'm going to pull my first conditional out. So if the ambient temperature output is less than or equal to 27 degrees Celsius. Okay, so far I've pulled in saying if the temperature is less than or equal to 27 degrees Celsius, these are the things that I want to happen. I am going to have my speaker off, set that to 0 hertz. Here's where the text output comes into play. You're going to click code output, create text. Give it a name that's easy to refer to later, and I'm just going to put light bulb efficiency, and my block's created, and I want it to say that this is a higher efficiency. If not less than 27 degrees Celsius, I'm going to duplicate my blocks so you can drag them from here. I am going to set the speaker to 500 hertz, and I want this to say lower efficiency. So that's our lower efficiency alarm. Okay, so to make sure this works, remember we've set the alarm feature on here, so the speaker is going to go, but I also have text output that's going to be on the screen. To get that up, I clicked on the code piece again, and I'm going to add a screen. I want you to be able to see the temperature over time data, but then what I did is I clicked the digits display and the second piece, select measurement, and go to user entered. Whenever you create text output or numerical output, you find it in the user entered section here, and there's my light bulb efficiency. Okay, everything looks good here. Everything looks good here. Let's see if our program works. I'm going to turn on my LED. All right, no alarm is happening. It's saying a higher efficiency bulb because it is. It's giving off less thermal output, which means more of that electrical energy is going directly to the light that's coming out of the bulb. Now you might want to run this for another 2 minutes, but I'm going to go ahead and switch out. All right, incandescent bulb in. Turn the light on. Let's try what happens now. We're a little over a minute in. Still climbing. And there we go. It took us about 2 minutes to get there, but this is what we anticipated to happen. I have the alarm going off, and then I also have the screen telling me that I have a lower efficiency light bulb right now. And that's what we were wanting to see, because the longer the light's on, the more thermal output is going to happen from the bulb. So again, this is a great investigation that you can do to check the proficiency of the light bulbs in your home and maybe help your family save a little money on that electric bill. Again, be safe using the incandescent light bulbs. I wouldn't want to touch this for a few minutes while it cools down. And thanks for joining us again. Good luck with your program.